Hello learners, I'm sending the answers to the questions that I gave to you. Reading this question to you, in the diagram ABCD is a quadrilateral having vertices A, B, C and D, all of which are shown in the diagram. DC produced cuts the x-axis at E, BC cuts the x-axis at H, and AD cuts the x-axis at G. F is a point on the x-axis such that BF is parallel to D. AGO is alpha and ADO is theta. First question, 3.1, calculate the gradient of DC. So let's start that calculation. Right, 3.1 gradient M of DC. So we're going to subtract and take the formula from the data sheet, y2 minus y1 over x2 minus x1. That will be equal to, you're going to subtract from C to D. So that will be minus 3 minus your minus 5 over 4 minus 0. Please do not make any mistakes in your substitution. It's important you do this carefully. Punch the whole thing on the calculator, or I'm working manually. Minus 3 plus the 5 will leave me with 2 over 4, and the final answer there is half. Right, that completes 3.1, just the gradient, 2 marks. Make sure you bank it. 3.2, question reads, prove that AD is perpendicular to BC. That means you need to remember the product of the gradients is minus 1 if two lines are perpendicular. So you must go find the gradient of AD. DC you already have in 3.1 and multiply the 2. Get minus 1, they're perpendicular. Right, let's go find the gradient we don't have. Gradient of AD is the one you need to find. DC you've done in 3.1. No need to rewrite the formula. We'll subtract now from D to A. So from D to A, it'll be y minus y, your minus 5 minus the 3 over 0 minus your minus 4. That leaves you with a minus 8 over a plus 4, which is minus 2. Or just on the calculator from where you substituted, and you can get the answer carefully. Now, to test out for whether they're perpendicular or not, M of AD times the gradient of DC will be equal to AD, which is minus 2, times half from 3.1. So half, 3 there. That equals minus 1. It is minus 1. So therefore, AD is perpendicular to DC. Right. Next question, 3.3. 3.3. Show that ABC is an isosceles triangle from triangle A, B, and C is not a complete triangle. It's drawn there. We need to find all three sides to check if any two are equal. Then it's an isosceles triangle. So we can find any two first, but we'll find the two that is in the picture rather than go from A to C. And if need be, we have to find the third one. Right. So 3.3, AB we're looking at. So distance formula, x2 minus x1 all squared plus y2 minus y1 all squared equals in there, not AB multiplied, it'll be, if I don't put that equals, that will now be equal to, from B to A, if I subtract, it'll be 3 minus the minus 4 all squared, plus then y2 minus y1 will be 4 minus 3 all squared. And if you're having trouble knowing which is which of here in your diagram, I'm going to write it on the A and B. We subtracted from B to A. That can be your x2, y2. Write it next to your coordinates, x1, y1, and subtract accordingly to avoid you making any mistake. I'm just going to clear up the diagram of what I just told you off. Anything to make sure you get it right. And then on the calculator, practice this. Make sure you can punch this whole thing on the calculator and get that final answer. And it should be 5 root 2. Must practice the calculator. It doesn't suddenly just become knowledge to you if you haven't done it before. Then now we're going to find BC, the other side of the triangle, to see whether they're going to be equal. If not, we're going to have to find the third side. And again, we'll subtract from C to B, 4 minus 3 all squared. x value subtracted plus, don't make a mistake and write wrong signs now, minus 3 for the y value, minus 4 for the y1 value. Again, very carefully punch in the calculator, and you should be getting 5 root 2. Now they both are equal. We have that AB is equal to BC. Therefore, triangle ABC is isosceles in short, right? So that completes 3.3. Now for 3.4, determine the equation of BF. And we were told, or we can see in the diagram, there's BF in the diagram. It is parallel to DC or A or DE. But DC is more valuable to us because we know that we did find that gradient before. So let's start 3.4. They want it in the form y equals mx plus c. And we already know m because it is parallel to a line whose gradient we found. So y equals half x plus c. All we need to now is solve for the c. And to find the c, go back to your line BF and you need to find a point to substitute. And yes, we do have the point 3 and 4. So we substitute point B, 3 and 4 into that. So y value 4 equals half into 3 plus c. Keep the c on your right hand side. C then equals 4 minus half 3 is 3 divided by 2. And subtracting carefully your calculator should give you c equal to 5 over 2. Put the c value, the gradient together, and give the equation of the line. Y equals mx plus c becomes half x plus 5 over 2. Equation of the line BF done. Right, then in 3.5, you're asked calculate the size of theta. Theta is at this point over here in the diagram. It's not even an angle of inclination. If we had any gradients for, our angles of inclination that we can use gradients to find for analytical geometry are all these angles here, right? And in the axes, they meet at 90 degrees, which we need to know because it's very handy, because right now we will be using it in this calculation because alpha is the one linked to our theta. Right, let me just clear up more here. Right, this alpha, and we got AD, the gradient of AD. So we can now find alpha because alpha is an angle of inclination. So in 3.5, we'll start like this here. Tan of alpha is equal to gradient of AD, m of AD, which means tan of that alpha is equal to minus 2 from 3.2. The gradient of AD was taken from there. So alpha then equals tan, I think squashing everything up and writing badly too, tan minus 1 of minus 2. But because it is a minus 2, you need to add 180 degrees, or you'll be finding an angle below that alpha angle, which is not what you wanted. You'll be finding a negative angle down here. That's not our angle of inclination. So on the calculator, if you do this, you should be ending up with alpha now equals, calculator and add 180 one time. You will have 116,57 degrees. Now going back to our diagram, 116,57 is there. You need to find theta. Now here is 90 degrees. Overdid it. We just need to look at that 90 degree there. Y-axis and x-axis are perpendicular to each other. You can use straight line 180 minus 116.57 and find the angle I'm dotting, and use angles of a triangle and find theta. 180 minus 90 minus that one we dotted. Or there's another property that alpha is an exterior angle to this triangle I'm drawing for you now. 90 plus theta is equal to 116. So that means theta would be equal to the outside angle, the exterior angle, 116,57 degrees minus the 90, and that should give you an answer of 26,57. Right, that completes 3.5. Let me clean up the diagram because we need to illustrate for the next question as well. Right, in 3.6, determine the equation of the circle with center as the origin and passing through C in the form of x squared plus y squared equals r squared. The fact that it's going to origin, this equation here is for any circle that passes the origin. So passing its center as origin, passing the point C would look like that. We don't know if it's going to any other point. We can't be sure, but it's definitely going to C. So C will help us to get that radius. Okay. Let's undo all that we messed up in the diagram and get back to the answer. So in 3.6, you're looking at x squared plus y squared equals r squared. And you have a point C, which we can substitute. You don't need to substitute the origin because it's 0 and 0, which will leave you back with x squared plus y squared. And C is 4 and minus 3. So substituting that in there will be 4 squared plus minus 3 all squared is equal to r squared. Must have the brackets for the negative. That will put it in your calculator and that'll give you 25. And we don't need to find the radius because we need r squared in the equation of a circle. So x squared plus y squared equals r squared, which is already 25, and that completes the equation of that circle. I hope this is helpful to you.